Welcome to qnawire.
In this question, we have a wheel. It's rotating with an angular velocity of 27 inches per second. It has a radius of 8 inches. Sorry, it's rotating with an angular velocity of 2 radians per second. It's moving in a linear velocity of 27 inches per second and slightly above the ground. And we want to find the velocities of points A and B. So we know omega is in the k hat direction, and it's in the clockwise direction, so that means that omega will have to equal -2 k hat radians per second. The velocity v0 is in the I hat direction, so that'll be 27 inches per second in our I hat direction. And our velocity of A with respect to the origin will be r times omega, and this will be in the j hat direction, so in the y direction, based on the rotation of it. So that's 8 inches times 2, so that's 16 inches per second in the j hat direction. We want to write the position here of r with respect to the origin, and that'll just simply be a -8 inches in the I hat direction. So that one's pretty simple. We can then find the velocity of A. The velocity of A will just be the velocity of the origin plus omega crossed with r with respect to O. So this will give us a 27 inches inches per second in the I hat direction, and then plus a 16 inches per second in the j hat direction. So nice and simple. So we then want to do the same thing for point B. The difference here is that P with respect to the origin is now -8 inches in the j hat direction. So VP would equal V0 plus omega cross that RP with respect to the origin. When we put the numbers in here, RP had that j hat, and we have a k hat crossed with the j hat, which will give us a negative I hat now. So we have a 27 inches in the I hat direction minus a 16 inches in the I hat direction, or a total of 11 inches per second in the I hat direction. So if we drop this on the ground, then the motion of the circular disc when it hits the ground will roll with slipping. If there's no friction, it will just continue in that motion as it goes.